Okay, welcome back to another video on the Maths channel. It's your teacher Mr. Lim here, and in this video we're going to be looking at perpendicular and parallel lines. So by the end of this lesson you'll be able to find the equation of a parallel line and find the equation of a perpendicular line. So let's have a look at the first one. How to find the equation of a parallel line. Well, what do you notice about the gradient of each of the parallel lines? So let's work it out. Let's call this one line 1. So M1 for the gradient. So M1, what is the gradient of the first line? We'll pick 2 points. Draw a right angle triangle. The rise is 2 and the run is 3. So the gradient is 2/3. If we were to pick 2 points from the other line, draw a right angle triangle. Rise is 2, run is 3. So the gradient of the second line is also 2/3. So we notice that the gradient of each of the parallel lines are the same. So the conclusion we can make is if 2 lines are parallel, they have the same gradient. So, are the following lines parallel? Here I've got 6 examples. I'll do the first 2 with you, and then I'll get you to have a go with the last 4. So y equals 2x plus 3, y equals 2x minus 7. We're looking at the gradients. Hey, they're both the same, so yes. What about the next one? The gradient is minus 3, gradient is minus 3. Hey, they're both the same, so yes, they are parallel. I'll get you to pause the video now, have a go with the last 4, and when you're ready to check your answers, I'll get you to continue playing the video. Okay, so we're going to continue. Question C. 5/2, 5/2. Yes, it is. Question D. 7 and 7. Yes, they are parallel. Question E. 2 minus 2. So no, these 2 lines are not parallel. And question F. 3/4, 4/3. They are not parallel. They have to be exactly the same. So now we're going to look at how to find the equation of a parallel line. So find the equation of a line which is parallel to y is equal to 3x minus 1 and passes through 5 minus 4. Well, in the previous video when we were looking at how to find the equation of a line, we said we needed 2 things. We needed the gradient and we needed the y-intercept. Once we have those 2 things, we can find the equation of a line. So, do we have the gradient? Well, because we know that it's parallel to this, the gradient has to be the same. The gradient is 3. But we don't have the y-intercept, so we need to work it out. Or we can just use the point gradient formula. The point gradient formula is y minus y1 is equal to m bracket x minus x1. And so with y1 and x1, we can just label this point that is given to us in the question, x1, y1, and we can just substitute. So y minus y1, well, we're minusing minus 4, which becomes plus 4, is equal to m. Well, we know m is 3, bracket x minus x1 is 5. We can now expand the brackets to give us y plus 4 is equal to 3x minus 15. And we can now subtract 4 from both sides. Y is equal to 3x minus 19 to get our final answer. And that is the equation of the line that's parallel to y equals 3x minus 1, but it also passes through 5 minus 4. Alright, I'll get you to pause the video, have a go with this question yourselves, and then when you're ready to check your answers, you can continue playing the video. Okay, so in this question it asks us to find a line that's parallel to y equals minus 5 over 2x plus 2 and passes through the point 2 minus 7. Because it's parallel, we know that m has to be the same as this. The gradient has to be minus 5 over 2. So we're going to label our point x1, y1, and then we're going to use the point gradient formula. Y minus y1 is equal to m bracket x minus x1, and substitute accordingly. So we have y minus 7 becomes plus 7 is equal to minus 5 over 2 bracket x minus, well, x1 is 2. We can now expand our brackets. Y plus 7 is equal to minus 5 over 2x plus 5. Okay, minus 5 over 2 times negative 2 gives us positive 5. We can now minus 7 from both sides to get y by itself. So we have y is equal to minus 5 over 2x minus 2. And that is our final answer. Alright, let's have a look at the second part of this video. How to find the equation of a perpendicular line. So what do you notice about the gradients of the perpendicular lines in the example below? When we have a look at the orange one, we see that the gradient is 3. But we have a look at the second one, you can see that the gradient is minus 1 over 3. If we were to multiply them together, m1 times m2, we'll get 3 times minus 1/3, which is equal to negative 1. So whenever we have perpendicular lines, the gradients will always multiply to negative 1. Well, we can also notice about this, if we have a look at m1, we can write that as a fraction as 3 over 1. So technically, the gradient of the second line is the negative reciprocal of the gradient of the first line. So here we've got 3 over 1. If we were to flip that, it'll become 1 over 3. And if we were to change the sign, it'll become negative 1 over 3. And that is the gradient of the perpendicular line. Or vice versa, if we were to take this one, if we were to take this gradient, flip it around, change the sign to become positive, that will be the gradient of the perpendicular line. So if two lines are perpendicular, the gradients are the negative reciprocal of each other. What that means is we just flip them and change the sign. Okay, flip them and change the sign. So for these examples, in the following questions, m1, the gradient of the line, is provided. Find m2, the gradient of the other line, if the two lines are perpendicular. So m1 is 5, or we can write it as a fraction as 5 over 1. Therefore, m2 has to equal to the negative reciprocal. So we flip it, and then we change the sign. So that's the gradient of the perpendicular line. So let's try question 2 together. Write it as a fraction. So m2 is flip it, and change the sign, becomes positive 1/3. Question 3. Flip it, change the sign. Question 4, flip it and change the sign. It remains positive. Well, it changes to positive. So, are the following lines perpendicular? I'll get you to pause the video here, have a go yourselves, and then I'll go through these answers. Okay, so let's have a look at the gradient. This is 3, this is minus 1 over 3. If we were to put this as a fraction over 1, we can see that yes, they are perpendicular. Question B. Minus 4 over 7, positive 7 over 4. Yes, they are perpendicular. Question C, 5 over 9, negative 9 over 5. Yes, they are perpendicular. Question D, 2 and 2. No, they are not perpendicular. In fact, they are parallel. Okay, remember we're only looking at the gradient. Alright, let's have a look at an example. Find the equation of a line which is perpendicular to the line y equals 2x minus 3 and passes through 0, 1. So this is m1. We know that m1 is 2. Okay. Therefore, the perpendicular line has to have a gradient of minus 1 over 2. Okay, because remember, we can write this as a fraction over 1, flip it, change the sign. We can now label this x1, y1, and use our point gradient formula, substitute accordingly, and we can solve. So y minus y1 is equal to m bracket x minus x1. Y minus 1 is equal to minus half x minus 0. Y minus 1 is therefore equal to negative half x. And we can add 1 to both sides. So y is equal to negative half x plus 1, and that's our final answer. Have a go with the last question by yourselves. Alright, now that you should be done with that, let's have a look at this question. So find a line that's perpendicular to y is equal to minus 5 over 7x minus 2 and passes through the point minus 6, 4. So that's the gradient. We want the perpendicular gradient. So we flip it and change the sign. So it's just positive 7 over 5. So we have y minus y1 is equal to m bracket x minus x1. Label our point and substitute. Y minus 4 is equal to 7 over 5. X minus minus 6 becomes plus 6. We'll expand the brackets. Y minus 4 is equal to 7 over 5x plus 42 over 5. And then we can add 4 to both sides. Y is equal to 7 over 5x plus 42 over 5 plus 4 is 62 over 5. And that's our final answer. So by now you should know how to find the equation of a line that's parallel to another line and find the equation of a line that's perpendicular to another line. And that's it for this video.